As we get older, and especially as we get to our mid and late 20s, it takes an immense amount of focus and energy in order to learn. But that focus and energy feels almost like an agitation for people, feels like it's something to back away from. But if we can learn to approach that and understand that that agitation is actually the circulation of chemicals, which is the brain and nervous system telling itself, aha, now I need to pay attention and change, we can start to actually modify the way that system works.
How do you think our relationship with learning has been formed over time, hearing from your own as well?
I think it was the great physicist Max Delbruck who said that, when teaching, assume zero knowledge and infinite intelligence. I try and keep that in mind. I think that we are all innate learners by virtue of the fact that this nervous system, as it's called, is really a map of our experience. The nervous system is there essentially to educate itself so that it can operate better in a given environment. And once one understands that, you start to realize that the forms of learning are many. Anytime you're teaching or learning, is you're trying to find a universal algorithm of how the brain works. And what I mean by that is that, all these nerve cells, they only can communicate through chemicals and electricity. It's really just meat in there, believe it or not. But there are algorithms that are universal. So whether or not one learns better verbally or visually, or whether one has a propensity for math or for verbal subjects, what is true for all of us is that the brain is there always asking questions and trying to make predictions about its environment. And I think what happens is when we're children, we are learning passively all the time. As we get older, and especially as we get to our mid and late 20s, it takes an immense amount of focus and energy in order to learn. But of course, the nervous system can still shape itself well into adulthood, almost certainly for the entire lifespan. But that focus and energy feels almost like an agitation. And I think that as children, we don't necessarily experience that agitation because for better or for worse, we can experience and change passively. Neuroplasticity just happens by way of pure experience. As we get older, mid-20s, early 30s, and so on, that threshold of agitation for people feels like it's something to back away from. But if we can learn to approach that and understand that that agitation is actually the circulation of chemicals, which is the brain and nervous system telling itself, aha, now I need to pay attention and change, we can start to actually modify the way that system works. So that's a bit of a convoluted answer to your question, but I think that at the heart of our nervous system is this ability, these algorithms by which it can change themselves. And it's on all of us to understand that that bit of agitation and discomfort need not be interpreted as discomfort. That's the edge where learning is beginning.
How can someone start thinking about how they should approach learning?
Terrific question. And fortunately, nowadays, we can look to studies done in humans that define some very key principles. The first principle is that the whole process of neuroplasticity and learning is really a two-stage process. First, there must be focus and alertness. That focus and alertness is associated with the release of neurochemicals, so-called neuromodulators, things like acetylcholine in particular, which sort of acts as a highlighter pen, if you will, for certain connections in the brain to later be reinforced. And the neurochemical adrenaline, which is also called epinephrine. Epinephrine, also called adrenaline, is associated with an increase in kind of agitation and alertness. So you need alertness and focus. And then the second stage is that it is only during periods of deep rest, in particular sleep, and something that I call non-sleep deep rest, which I've given an acronym because scientists like acronyms, NSDR, non-sleep deep rest. Things like yoga nidra, things like shallow naps, things like forms of meditation that don't involve a lot of focused concentration. It is only periods of intense focus and alertness followed by periods of deep rest that allow the nervous system to change. And there is an abundance of evidence for that. So that's the first thing to understand. The brain actually rewires during deep sleep and rest, because during deep sleep and rest, naps, yoga nidra, deep sleep, there's a replay of the very same cells in the brain that were active during learning, oftentimes in reverse for reasons that are still not understood, but at a much higher repetition rate. So you're actually getting repetitions while you sleep. This is why one will strain to learn a language or a motor skill or maths or something like that over and over and over. It doesn't happen. You take a couple of nights sleep, take a break from it, and all of a sudden it's there. It's because it happens in rest. Now, there's some other things that one can do to enhance this process further that are arrived to us from good data. First of all, there's a so-called ultradian rhythm, which is the 90-minute cycles during which we can focus pretty well for a duration of about 90 minutes. Of course, flickering in and out of focus. Nobody really focuses for 90 minutes straight unless they've built up that capacity or they are very interested in what they're learning, right? They're just wrapped with attention. Usually people flicker in and out. And of course, nowadays, there's a lot of literature and ideas about ways to maintain focus. Put the phone away, limit noise. Some people like background noise. Some people like music. Some don't. It's very contextual, highly individualized. But 90 minutes is sort of the batch of time that the brain can focus really hard on one thing before it needs a true rest of an hour or two before you can go back to learning or working very hard. The other thing is that there's some very interesting data showing that shallow naps, or NSDR, non-sleep deep rest, done within 4 hours of one of these 90-minute learning bouts can be very beneficial for accelerating learning. And then there are these incredible data on so-called gap effects. So there have been studies now of skills that are physical skills, mental skills, where people will, for instance, try to learn scales on the piano, or a math problem, or a spatial problem, or a physical skill. And then at random, every so often, a buzzer will go off and the person will just be told to do nothing. Sit there, eyes closed or eyes open, and do nothing. Just stop the learning process for about 10 seconds and then return to doing what they're doing. These are these little micro rests. It turns out that during those micro rests, the hippocampus, a brain area, as you know, that's associated with learning and memory, and the neocortex, also associated with learning and memory, undergoes replay of the thing that the individual is trying to learn at 20 times the speed, also in reverse, just as in sleep. And that can lead, and has been shown to lead, to accelerations in learning. So whether or not you're a child or an adult, every so often when trying to learn something, just pause for 10 seconds or so. Do your best to just clear your mind. Of course, it's very hard to clear the mind, and then go back to the learning task, as it were. And that has been shown to significantly accelerate the learning process and the retention of newly learned information.